time of year.
Yeah. Chuck sent me the stuff a couple of days ago.
Okay.
Yeah.
Okay, you should be on now.
Well,
Okay.
doggone it, I guess we're on now. Hello there, everybody, cosmic cats and astral freaks. On behalf of the guys on the screen with me and my voice, been climbing into those damn chimneys. Happy holidays, everybody. For the Jewish folks, it's Happy Hanukkah. For the Christians, it's Christmas week. And doggone, what a time to lose your voice.
Mm.
It's our 200th program, you know that? One more in this year of 2024. And it's the Santa Barbara Astronomical Unit for December 23rd through the 29th. The Grinch got my voice. SBAU, that Santa Barbara Astronomical Unit, is based at the Museum of Natural History, up behind the museum, up behind the mission. I'm the vice president. I'll introduce you to the group here in a minute. This is our weekly vlog, and it's, like I said, number 200 for the 23rd through the 29th of December. SBAU Astro Hour. Maybe if I talk quietly. Here's what we're going to talk about. We're going to relive winter solstice. We're going to zoom in on a dim comet up in Cygnus. Couple meteor showers to talk about, the Geminids and the Ursids. Moon's reaching apogee, its farthest point from Earth, and 'tis the season to find one of the brighter blotches out there. We're talking about the Christmas tree cluster. And by golly, it does look like one too. Our red planet brother is in the same part of the sky and in opposition. And have our Earth days been getting longer or shorter over the billions of years? We're going to find out as we meet the newly reelected president. Like myself, I was reelected, Jerry Wilson.
Ho, ho, ho.
Sorry about this, guys. Maybe it's this damn hat. Maybe if I took it off, but then you'd see how bald I'm getting. He's married to Pat Forgy, and he's been reelected, I guess, 6 or 7, 8 times since the late 20 teens. Chuck McPartland, who's married to Pat, is on screen. You know, that red Santa hat doesn't really clash with the blue and yellow of the Ukraine flag. I hope you can keep that up there. He's married to our merchandise manager, Pat McPartland, who was also our beloved treasurer, also reelected. And she really wanted that gig. Tom Whittemore is with us. He's married to Maureen, former Westmont College science instructor, had his own lab and now edits our monthly newsletter and does a darn good job, and that's got to stop. I'm sorry. Jerry, we also need that damn article from you, and I need a new voice. Can one of you make sure I get a new voice for Christmas?
I think I gave you this voice.
I guess so. I was talking fine 2 hours ago, and I did something that probably blew it out. I screamed. I did a primal scream in my house, thinking that would, loosen those damn cords. Hey, there's let's see. Tom is married to Maureen, and Tim Crawford is on board. Doesn't like to light up his face, but just as well, we're not missing anything.
I can do that. How about that?
There you go. I'll turn it off. We don't want to see your face. I'm sorry.
Okay.
Tim is an expert on telescopes. He loves us. He's been with us forever. Longtime member, married to wife Karen. All these lovely ladies take care of their men, and they certainly support us. Oh, and there's Bruce. Finally logging in. Bruce Murdoch.
Hi,
Who
Bruce.
happens to be married to a lady by the name of Bonnie. And he's also president of the Santa Barbara Theater Organ Society. And I'm getting my voice back slowly. We have a fun time doing this every week. And we're not going anywhere. And we're building up some viewers. We've got over 100, I think, regulars. It's not like Joe Rogan or Neil deGrasse Tyson's vlogs and podcasts, but we're doing okay, including this little lady that has seen every one of our shows, but she can't watch them live for some reason. She already sees the ones that are archived. So we have silly cartoons to start the hour because it's time. Tis the season to get silly. And here we go from Jerry. This is the dog from hell. Yeah. An extraterrestrial green dog and a UFO flying in low over a couple of paleontologists, and he's beaming back. You know what, man? These humans are digging up the bones we buried. I thought it was the Lord that planted all those as a joke in Genesis.
Right.
All right, you're going to have to increase this. I didn't write these. I can see it. couple of ravens are talking during a total eclipse of the sun. People down below are wearing their glasses, and sure enough, one bird says, oh my God, what happened to the sun? The other says, these damn humans. They watched it through some crazy glasses, and sure enough, it disappeared. That's the reason. There's a ring on that one. This one you're going to need to explain. All you need is LOVE,
Yeah, these are
four
different
equations and
That's
stuff.
algebraic expressions that if you plot them, they will give these. This is a graph of that function.
Mhm.
Y equals 1 over X. That's a real live, that's an absolute equation.
Yes. As x gets bigger, the inverse of it gets smaller. So as you go out on the x-axis, the y value gets real small. And as you go
Okay.
up the y-axis, the x value gets real small.
Called a hyperbola.
Yeah.
Yeah, rectangular hyperbola.
All right,
this-
you might
this
as well
one
do
is-
this, Jerry. The O and the B and the E.
Yeah, these are the expressions that give this function. This is the absolute value of minus 2 times x. So that gives you the slope, and the absolute value
Is
gets
it
the
zero?
same on each side. So you have a negative x over here, but you get a positive y. You have a positive x over here, but you get a positive y.
Are
So
you
if
talking about the bottom or the O? The E
the
or the O?
v,
The V.
the v,
You're down to E. You've actually used these formulas?
Oh, yeah.
yeah,
The point of the V is at the origin.
yeah, these are very simple algebraic expressions. You run into these in high school, trig.
Yeah, well, Algebra 2 introduced quadratic, the X and Y. Algebra 1, I think, just stuck with X. Everybody can figure that out.
No, it's squares when it's quadratic, Ron.
Right,
Yeah.
Is that what that means?
Here's
Yeah.
these are squared.
right. The radius of that circle, Ron, is 3.
Yeah.
Well, I knew that, of course.
Okay.
Okay. See,
Well,
you don't
Jerry,
need
if
an explanation.
you don't have anything else to write about, you can write about that.
Yeah. You send the
Okay,
formula
here's-
to your girlfriend in class.
Yeah, a couple of marshmallow men are talking about the meteor shower. You got to watch it tonight. And the other one says, "Oh hell yeah!" And sure enough, there's a meteor getting a shower, washing down a dirty
Okay,
rock.
that gets the corny joke championship tonight.
I know. That's a Whittemore witticism. All right, this is sort of interesting. This is a thought provoker. Being a science writer is harder than being a sports writer, this woman says, because sports writers don't have to deal with people who think that basketball doesn't even exist. Of course, we know NASA stages all of them.
Yeah, good ones too.
Carl, was that okay? No picture. Here's a bunch of, you're going to need to change the brightness on this a little bit. I thought I
That's
memorized.
trick. I'll just read it, unless you can't see the dinosaurs all hitched together.
We can see the dinosaurs.
Okay,
The prehistoric reindeer set
Yeah.
up ready for Christmas Eve. And what's happening there? What are they saying?
we have Dasher and Dancer, Prancer, Vixen, and Cupid. But wait,
Where's Conway?
where's Comet?
Here
And down here,
comes
this
Comet.
little face is saying, dash away all.
Okay, it's their last ride. Okay, it was 65 million years ago. Reality check. Is that it? You're not going to do the you did the bones, the shower, the sports. I guess you got it
Yeah, I
all.
think I got them all there.
Carpenter puns. Okay. Puts me
Okay.
in a silly mood. Now I'm ready for the real serious stuff. I'm going to try
You
to
got your
grasp.
voice back too, Ronnie.
I slowly. Yeah,
Yeah.
maybe I'm trying too hard. Okay, what is this? Oh, this is fascinating stuff here. Did the
4.5
day longer?
billion years ago, Earth's day was less than 10 hours long when the moon first formed. So
Wow.
we were rotating we were rotating not quite as fast, but as many revolutions per hour as Jupiter is now.
Hmm.
Of course, Jupiter's a much bigger body, so if you're on the surface of that, you would be traveling much faster than the Earth going around in the same time.
So it's slowing down from what? Friction?
Tidal forces.
Yeah, about 2 billion years ago, a day was 19 hours long. So the moon has moved away from the Earth,
Mhm.
and that has taken energy out of the Earth's rotation, since it's a coupled system, and that is shortening the day progressively.
But now it was created by a collision with something, wasn't it?
The moon that's the current belief. They're still working out the details of it, whether it created large chunks or whether it created a great big donut-shaped cloud of dust that then collapsed into the moon and back on the Earth. So when the dinosaurs walked the Earth, which was about 70 million years ago, an Earth day, getting longer now, is 23 and a half hours, and a year lasted 372 days.
Okay. If a planet like Mercury, for example, doesn't have a moon, would it never slow down?
Not from a moon moving away, but it has its own energy loss systems. It's under tidal forces from the sun, and so the inside is slowly probably it's not enough for like Io to make volcanoes all over Mercury, but these things do lose energy, and sometimes not very much if they don't have a moon, but
Right.
these systems are not perpetual forever. Here,
Yes.
the moon is gradually drifting away from the Earth, causing Earth's rotation to slow down, lengthening days. And of course, now it's 24 hours long and 365 and a quarter days long.
Is it not something like a foot a year that it's moving away?
It's some small amount like that.
It's
Yeah.
like an inch.
Yeah,
Okay, I knew it was
is what I
small.
recall. So there will be an era in the not too distant future, not that we'll live to see it, but where total eclipses of the sun are impossible because the moon is too far away and too small to block the sun.
Yeah. And Ronnie, do you know why we know that the Earth, the moon is gradually getting further and further away?
No, how is that? Why?
So the astronauts, Chuck could tell you which Apollo it was, but the astronauts left these cubical French mirrors
Oh, yeah.
on the moon, and we shine like a sodium laser at them. We can figure out how rapidly or slowly the moon is moving away from us by time of flight.
You suppose is that normal? Do most moons want to come into a planet, or does it matter?
Well, this is a tidal issue. So, as the moon and the Earth tug on one another, the moon tugging on not only the oceans, but also the ball of the planet. We slowly give up energy to that and then give it, as Jerry said, to the moon drifting away.
Now,
conservation of angular momentum is the big phrase for it.
Right. On Mars, one of the moons is actually approaching Mars,
Okay.
and in the future, will land on Mars rather spectacularly.
Wow.
It's like a crashing meteorite.
Yeah.
It'll probably be like the comet crash on Jupiter, where the Phobos will get torn apart into a bunch of littler pieces that will.
Right.
Yeah. Hitting a Roche limit or something, Chuck?
Yeah.
Yes. Yeah.
Okay.
So in 200 million years from now, we will have a day that is 25 hours long.
Okay.
So it's not a rapid increase.
And it's
Yeah.
slowing as it gets farther away because
Yeah.
the tidal influence.
And from these pieces of data, you could literally figure out, what the rate is, right? And it's clear, it's not linear. It's not linear.
We got a bunch of
I'm not sure
exclamation.
I'm not sure what the amount is. I know our day right now is 23 hours, 56 minutes, and 4 seconds long.
Yeah.
Mm-hmm.
And I don't know how many seconds per year we lose.
When was the last time we had a leap year? I don't remember.
Every
20
4 years.
Yeah, 4 years. Yeah.
It's every 4 years.
For example, we skip them in every 400-year intervals, things like that.
Yeah. In round numbers of zeros, we skip them. 2020, we skipped it.
Well, this looks like a bunch of exclamation points on the screen.
This is a picture of a comet. It is comet 333P linear.
Mhm.
This was taken just about a month ago, 2024. And these are individual photographs taken for a short period of time. And they're stacked so that the comet is stacked directly on it, but the star background is offset. Now you could stack it so that the stars are points, but then you'd have this number of comets in this pattern. And the idea is to bring out the faint detail in the comet, so we stack it so the comet is in registration. So this is, it's not a bright comet. It's around 12th magnitude right now. So, but it is an object we can look at. Here's mine.
Is
And
linear a common name on all comets or just this one?
Linear is a system that looks, it's Lincoln Laboratories Near Earth Asteroid Research or something like that. And
Okay.
so it's just like Atlas. It's a system that looks out there and they discover multiple comets.
right. So a lot of comets are named linear. You just remember this as 3 cubed p.
Yeah.
So this one starts with September 1st, 2024, going up through October, November, December 10, December 20, December 30. So we're right about there in the comet in the background. Cepheus, it's in the constellation real estate of Cepheus here. It's close to the North Pole, so it's up all night. It's a good thing to look for. This is a map of the region, and this cursor's put where the comet is tomorrow night on the 24th. Oh, it's not in Cepheus because there's a little border around there. It's in Cygnus right now. But you don't see these borders on the sky, on the star at all. I mean, on the sky, unless it's super clear. So, so it's almost halfway between Sadr and Altus, about a 1/3 of the distance, and a little offset to the west. This is west, I guess.
Well,
You could probably make a big right triangle from Mu Cephei and Sadr.
Did I miss that? Does it have a tail or not?
Yeah, it does.
Yes.
It's a tail if you take a photograph. It's not a bright trail.
With an open lens, right?
Yeah.
And those exclamation points are stars going
Yes.
by.
Each little round dot is a separate photograph, and these are stars. So this is 1, 2, 3, 4, 5, 6, 7 photographs, and they were all stacked to register the comet.
And the comet would be going which direction in that photograph?
Can't tell but you can tell which way it points to the sun. The sun's down here,
Okay.
but
And
here
do
you
we
can
know
tell which way it's going.
where is it based? Is it based in the Kuiper Belt or the Oort cloud or just part of
This
the?
is actually a very short period comet. It's only 8 years, 8.7 years. It's
Okay, so
called a Jupiter family periodic comet, and it is in retrograde orbit, which Jupiter kindly put it in.
So it's out there in the Trojans?
No.
Oh, you
It's
said
in orbit.
Okay. Well, I think there are some rocks in Jupiter's orbit called the Trojans, aren't they?
There are,
Yeah.
but those don't swing close to Earth. And this one was once thought to be a hazardous to Earth, but later simulations showed that it was a comet nucleus that was possibly put into its current orbit after an interaction with Jupiter. And in the future, it will collide with the sun or migrate beyond the orbit of Jupiter. So it's in a very unstable orbit, but it's not a danger to us.
Not exactly collide with the sun. It's going to vaporize into the sun. Interesting. Fascinating. I love this program.
It's classified as an Amor asteroid, AMOR. I don't know
Okay.
that classification, so I can't illuminate.
That means that its perihelion is just outside the Earth's orbit.
Okay.
It doesn't mean it's in love with the Earth.
Yeah. It means it's an Earth grazer.
Right. So people didn't know that when they first saw it, and they thought, oh, maybe it's really in love with the Earth. Yeah.
But we'll probably see it a lot more than we see the other comets that go way back out and take.
This one will probably never become a naked eye object. It's going to become an amateur telescope object. So while we're out there, it's in the region of these two things, which we have seen several months previous to this. An open cluster, NGC 6939, and this beautiful spiral galaxy face on, NGC 6946.
Is that the fireworks galaxy?
I don't recall seeing that there. It could be.
Looks like the Playboy head.
Oh, this is.
Where do you get that?
The upper two arms and the middle, the bottom one is.
Oh, I see the
rabbit seal.
rabbit.
Yeah.
Yeah.
I see.
Okay. We know who had a subscription to that.
We all
So
did.
this one always is odd. It's got this nice little ring of stars there, and then this dark region right there. It's got another dark region over there. Could be a cloud of nebulosity. That's usually what they are.
Yes, Chuck, the 6946 is the fireworks.
Oh,
Okay, I
okay.
thought it looked familiar.
So 6949 above.
I don't see 6949.
Well, that's
The title above the
JPEG
picture.
title.
Excuse me. Yeah. Oh, that title was provided. So maybe I've got the text wrong. 6946. This is 6949.
Oh,
So it wouldn't be the
Well, it looks a lot like the fireworks. So
it
I don't
does.
know. We
And
can
the
leave it
reason-
ambiguous.
The reason that one galaxy is called the fireworks galaxy is it has a unusually large number of nova in it, and supernova, I mean.
Yeah.
We can see from here.
that's got to be it, because I'm looking at pictures on my other computer and it looks identical.
Okay. Oh, no, this is just me screwing up. This is my title that I wrote for this picture.
Oh, okay.
This should be 6946 there.
Okay. Yeah. So that is fireworks.
Yeah. So, yeah, this is the number I assign at the beginning that gets them in order.
Okay.
So next one should be 10. Yeah, 10. Okay. So this is very early morning. This is 6:30 in the morning, which it is still dark. At least as far as I'm concerned, because I'm asleep.
It's starting to get light. I
Yeah.
saw Vega come up at 5:23.
Okay.
Yeah, this morning. Yeah.
That's not in this picture, I see.
No,
That's-
not
yeah.
be further to the north.
Uh-huh.
Could you see the sky? Because here all I saw was a little cloud, a layer of thin
Little
Yeah.
clouds.
clouds. It's
Oh.
like someone painted my windows white last night.
Oh,
It was so foggy. So this has got, of course, the stellar famous stars, Zubin El Shamali and Zubin El Junior, my favorite pair. But it shows Mercury is in the morning sky. And also we've got Antares.
right. So you can cue off of Antares, Jerry, to
Yeah.
pick up Mercury. Yeah. And I did see Antares the other morning.
Yeah, Antares is
southeast.
right
In the
down here.
southeast.
Oh, there it is. Okay.
Yeah. So right down next to M4.
Mhm.
This is a spectacular summer area around June. Look at this. It will be overhead in the evening. Mercury is approaching or at eastern longation, or western longation.
Yeah,
Back
western.
to western. And so it'll be returning back to the evening sky shortly. Now this is what I call the straggler. The Geminids had a poor prospect this year because it was during the full moon. Difficult to look. And the Ursid from the Ursa Minor radiant, there's the radiant right up there, the group blue dot up near Kochab. No, there's no L in it, Kochab. So in the Little Dipper. And the Ursids come from this. They peaked last night, but there are some stragglers for almost every meteor shower. And so looking at it after midnight tonight, if you have a clear sky, which I don't, then you can see some stragglers. The only equipment you need are a pair of young eyeballs and a You don't need much else. It's not a real heavy shower. It produces about 10 meteors per hour. But if you're up for an hour relaxing at night, just you and your chocolate and the Oreo cookies, don't fall asleep, you could see still a good shower tonight.
Well, can you explain to me again why the radiant thing, are those meteorites or meteors coming from that one spot on Ursa Minor? Are we passing through a trail? Is the Earth heading toward it?
No, we passed through it last night.
I
So-
know, but I can't visualize why it would come from one part of the sky.
Because that's where the orbit of the comet was.
Right. Let's suppose, you know what happens when you're in the morning sky between midnight and dawn. We're on the side of the Earth that is on the front side of the Earth. So you're leading into space. And so the Earth will sweep up all the debris and stuff, and it will come in as meteors from all over the sky. If you have someone, and that's like your rain on the windshield of your car, you get most of the rain on the windshield. You don't get any rain on the back window. So now when you go through a meteor shower, it's like your neighbor kid took out a hose, and as you're driving out of the driveway, he squirted his hose right at your windshield. See, it's a beam of water that comes and it runs right into you. So you'd see that would be a water shower, of course, hitting your windshield. But we just passed through this beam of water that the kid is shining on you. That's an orbit for dust for a past comet that it left all that dust and tail behind. And so we passed through the dust cloud. We know where the center of that dust cloud is, and so we can know when the thing will peak, and that's when you get the most meteors. But as it spreads out, they are spreading out. It becomes less well defined, and it spreads out over more days for the shower to actually occur.
So all these different meteor showers we get during the year come from different spots.
Yes, different orbits.
Different
That was where a comet once left, and it left these tread marks behind.
I'll be damned. Okay, I'm getting it.
Okay.
Apogee.
Now this is the last quarter moon, which happened
2 nights ago.
Sunday afternoon, about 2 o'clock yesterday, Pacific Standard Time.
Yeah.
And this is not a line I drew, although it looks like it's done with a ruler, but I picked the map when it was exactly last quarter, so you get a very straight region. There's a region down in, I can never find it again when I get over here on this thing. But one of them is the Hyginus Rill, which is along this, I think it's right in this area or this area. And the fellow in Germany, Uwe Mehling, has taken a really good detailed shot with his
16 inch.
400 millimeter
16 inch.
Cassegrain. Yeah. Now this is a sequence. It's a video sequence he took with 5,000 frames.
Wow.
And then he had the software take the best 20% of those frames and stacked them, and then did some minimal focus processing on them. But this is an absolutely stunning picture.
Yeah.
You can see these pockets down here. This is not an impact crater feature. This is where lava once flowed, and it had a tube, and the tube collapsed. Although I think this one is where the tube came out and flowed on the surface. But in here, and these might be little other cones that formed on the lava tube. So, but that's a very clear picture of it. He does absolutely excellent work.
Yeah.
So that would be equivalent to a river valley here, not a Grand Canyon.
That's closer to it, yeah. But it's more
But this is not an erosion.
right. This is
a collapsed tube.
Yeah. You find these around the world. I've been through one in Hawaii, a lava tube you can walk through.
Right. There's some up near Bernie Falls up north. in California.
Yeah.
Also in Idaho.
Yeah, they're all over the place.
Mhm.
And these things are, and there's a lot of stuff up here that may not be collapsed, and those are being viewed as, and elsewhere on the moon, and those are being viewed as possible habitats. Because if you get 3 meters of lunar regolith above you when you're on the moon, that will protect you from the solar radiation, the proton bombardment from the sun.
3 meters? Is it 3 meters?
Yeah.
3 meters, yes. That's
So 10 feet.
Yeah.
Huh.
There's a lot of lava tubes in the northeastern corner of California.
Right. Those are the ones I
And I
know,
went-
near Bernie
I
Falls.
went into one of them with my Coleman lantern. And as I walked into the tube, the lantern got dimmer and dimmer and dimmer. I said, maybe this is such a good place to be.
Well,
The
it's dark
dioxide
rock.
building up.
It's dark rock, and with its interior surface structure, probably just as an effective black to absorb your light.
Or just
No,
lack of oxygen.
Lack of oxygen.
The Coleman lantern itself was getting dimmer and dimmer.
Oh, that's right.
It
I
was
was
running
thinking
out
of
of
batteries.
oxygen.
Yeah, well, how was your canary doing?
I didn't carry one.
Okay. So this is the moon on Tuesday, tomorrow morning. It's near Spica, and it's now a waning gibbous moon in the morning sky, which gives us the evening sky to go through all the faint fuzzies. These are the faint fuzzies up here that we're going to see at night, in the middle of the night in April and March, up here in the Virgo cluster of galaxies.
Why then? Why not now?
Well, you can see it now if you get up at 7 a.m. and the sky will not be this dark at
No.
7 a.m.
Not at all.
Yeah, and so you won't see them then. But if you wait till April, you'll see them at the night, in the evening.
And if you wait till May, they'll be overhead as the sun sets.
Yeah. Now this is a map. This is not a photograph. This is a map of Mercury on December 20th, 2024. And this is a map on the 24th, 4 days later. So the Mercury is rapidly going around the sun and going, I guess it's past inferior conjunction. That didn't sound right. Yeah. Anyway, and it's going towards superior conjunction. So it's going toward more full.
Yes. Yeah.
And at this part of it, its combination of proximity to us and the amount shown gives it its brightest appearance.
Well, then what are perigee and apogee?
That's to the moon.
Just the moon? It's not the same thing you were just talking about?
Well, G means Earth, Ron. So it has to be something orbiting the Earth.
Right.
Oh,
Yeah, this would be parasol and
Perihelion.
that's it, helium. I was wondering because a bumper shoot. But anyway,
parasol's good for me.
you can see how fast the Terminator is moving in just 4 days. Mercury's really booking it around the sun.
But it's tidally locked.
Yeah, sort of.
Sort
It's
of. Yeah,
It's 3 to 2.
synchronized.
it's because of the slightly erratic orbit shape, right? The oval, the ellipse.
Combination of that and the fact that its mass distribution is not spherically symmetric.
Give it time.
Okay, here we have okay.
We're heading to the Christmas tree nebula, aren't we?
Oh, that's it. Yeah, 2264. It's up here in Gemini. This is Mars down here. And this is late in the evening. It's 10 o'clock in the evening on December 24th, tomorrow. But it'll be pretty much the same tonight. Our dog walker just got here. The dog's really happy to see him. That's what you hear in the background. And of course, it's easy to find this area because this is an unmistakable asterism up here, Orion the Hunter. But this is the region. There's a lot of nebulosity along here. There's a big loop here Barnard's loop of hydrogen. And then this is another little region of nebulosity, which we're going to take a look at. It's called the Christmas tree cluster. And this has been altered in processing to make it look more like a Christmas tree. Nothing's been moved, but the colors have been enhanced. But
It made red into green, right?
yeah, you got to remember that all colors you see in an astronomical photo are false colors. There's
Still
someone's opinion of what it should look like.
got some great lights on it.
Yeah. And this up here, I've seen this, one of the first objects I ever saw in books on astronomy, the Cone Nebula. And I thought there must be something really bright down here that's causing this shadow. I had the right idea, but the wrong physical effect.
Yeah.
So
Sometimes called the Madonna and Child.
Yeah.
Madonna and Child, yeah.
Wow.
Now, when I've shown the Christmas tree cluster out at Bukhara to guests when I was a more regular participant in outreach that way, it was usually upside down.
Mm-hmm.
Yeah.
And people
Most
don't
things you look at
recognize.
are not right side up.
Say that again, please.
I say most things that we look at in the night sky are not vertical. They're at some
Yeah.
angle.
Yes, and
this-
and the scope you look through will change the angle by 180 degrees sometimes. So
Well, you can move your diagonal around and rotate the image.
if it has a diagonal, yes. I saw
Yeah.
a kid with a straight through one time was looking through my telescope with straight through optics, no diagonal. And he looked up at something and then because we were looking at oil drilling platforms out in the ocean. And he looked in there and then he took the eyepiece and he tried to rotate the eyepiece to get it. And I told him that's not going to work. And he looked at me like, how stupid can you be?
Yeah.
But Jerry, what kind of an eyepiece? I mean, what kind of power is this? A low power
This
optic?
is low power, yes.
Okay.
But
is
but
white.
this is the Christmas tree cluster. It's not a nebula.
It's a nebula. Oh, it's got a Christmas tree cluster in it too.
Right.
So
the one I showed to people out at Westmont is M Messier 103.
yeah,
It's up in the northern sky.
yeah. And that's the one I was showing was a cluster, not this.
Yeah.
Not this.
Mm-hmm. Mm-hmm.
If people, when they look through my eyepiece, say, "Hey, your image is backwards," I said, "No, it isn't. I have a prism. It doesn't reverse the image." If you have
I just tell them to turn around and look again.
Wow. Looks like every holiday has its own cluster or nebula.
I have not seen a jack-o'-lantern cluster.
Well, there's something out there that happened at Halloween. I forget what it was. Which
There's an owl cluster. There's a screaming skull nebula. There's a ghost nebula. Yeah.
I haven't seen a jack-o'-lantern, but there's the witch's head and,
Right.
Witch's
That's
head,
around.
and the witch's broom.
Yeah.
right?
That's
So
Well,
okay,
I gotta tell.
Mars is near opposition.
mm-hmm.
We gotta go
Very
there.
bright, very red right now.
Yeah.
Here we go to Mars.
Now
Wow.
this is a Mercator projection of Mars,
Mhm.
so it is appropriately distorted. This is what makes Alaska and Greenland look so big
Yeah.
Yeah.
and stuff, but they're
Yeah.
not that big. But here it's taken a polar cap and smeared it out into a linear structure.
Mhm.
Now you sometimes ask why, when we're looking at the microwave background, and which is usually presented as an ellipse with that, you
Right.
ask, why is it an ellipse? It's an ellipse just because that's the way they chose to project it on a flat surface. And a Mercator projection is what this guy chose to project this on. So there's no reason that it has to be this way, and there's no reason that the microwave background has to be on an ellipse. So it's just a way of displaying it.
Do they ever superimpose the stars either as little black dots or nebulae,
there's-
as little fuzzy patches over all that blue and yellow?
No, it would obscure all that, all the fine structure that you're trying to get meaning out of. It would not make a good picture. It would be a very busy, very complicated structure and be, in my view, very confusing. But remember, scientists are after information. They're not after a pretty picture. When we're in this hobby and we do astrophotography, we're after the pretty picture. And about halfway through your image processing, the last thing you do is a linear stretch. And up until that step, your data has scientific value. Once you do a nonlinear stretch from there on, it has no scientific value. You've arbitrarily distorted color, tone, all sorts of things. So that's where we depart from it, and we start trying to get a really good picture. And some people are super good at it. Some people in this club are super good at it, and I don't put myself in that category. So, but this is a map of Mars. I don't know exactly where the, did I write down who did it?
Don't see it.
Well,
Where's Olympus Mons on there?
It says NASA JPL Caltech, so.
Okay.
Yeah. So NASA JPL Caltech runs a lot of different telescopes and space probes. So this might be like a US Geological Survey map of the dark spots. But the reason this shows the dark spots is that this is what you see when you look visually through your telescope, if you can see any detail at all. It's not obscured by a dust storm on Mars, which sometimes happens and you can't see anything on Mars for like half a year, half an Earth year. But these dark features, these things change over time. And when people saw them up till about 19, what's that? Someone's got a feedback loop. I hope it's not me.
It's Bruce.
What?
It's Bruce.
It's me, and I don't know how to get out of this now. Let me turn on.
I muted you. No offense.
Only
So-
three things identified there on Mars.
What's that?
Only three things I see ID'd.
Yeah, the major thing is Syrtis Major over here, Mars Samarium, and Hellas down here, the bright spot. Now, these dark spots, this is what you see on this, and these change over the course of a Martian year. And up until about 1960, if you got a textbook and you looked at Mars, you saw drawings of canals, and you saw these things as like oases on the canals, but you can see there are no canals. But these things do change. They move around a little bit. They expand and they contract. And the idea was the water was flowing through the canals down to these regions, and these regions were plant material. And so when the water got there, they expanded and grew. And then later in the years, things dried out in the fall, they would shrink. Now, the current idea is that these are regions of dark minerals, which have been identified because we've got probes running around on them, leaving tire marks. And we know that the reason they change is because of windblown dust that covers parts of them up with the red stuff. And so that wind blows dust onto them and it blows dust off of them, much like it blows dust onto the solar panels on the rovers and also then cleans them off, and the rover has another year or two of life. So unless it runs into a rock and gets stuck, which has happened.
Would it be fair to say that the dark areas are lower in elevation and may have been ancient oceans?
I would have to say that I don't know the answer to that, but let me speculate, and that is that since these persist with all the dust blowing around, that these are probably higher regions which the dust can get blown off of. Dust would get blown into lower regions and stay there, in my view. So
Yeah,
if there's an element of elevation there, these are probably higher.
Hellas is a basin, for example. So that's a lower area, and it's quite bright here.
Yeah.
So it's more like the distinction between rocky deserts and sandy deserts.
Yeah.
Okay. But
in fact, Hellas Basin, one of the ideas for the two moons, for Phobos and Deimos, is that they're debris from the impact that formed the Hellas Basin.
Oh, really? A lot of those moons are created that way. Ours was probably half the ones around Saturn.
Once you get into the 100 plus in Saturn, you're getting into major collision territory.
But now there's more ice and dry ice on the North Pole and the South, isn't there?
The South Pole, I think, is the major ice one.
Really?
Yeah, and they have each of them has water ice and dry ice, but most of it is dry ice. And the dry ice sublimes away, leaving the water ice. And when the polar cap grows, that's dry ice precipitating out of the atmosphere on top
Well,
of the
dry ice and CO2 are the same thing, but it's never in
Yeah.
a liquid form, is it?
No. Air pressure's too low on Mars.
Well, anywhere. I don't
It
see liquid.
sublimes.
Okay.
It's when I was working before I retired, I spent some time visiting Sandia National Laboratories in Albuquerque, New Mexico. And I walked into the plant one day. It's high desert, and it was just freezing cold, and it had rained, it snowed that night, so there was snow on the ground. And I was freezing, and I went inside, and then about 3 o'clock in the afternoon, I came back out to go to catch my plane home. And I looked down, and there was no snow on the ground, and nothing was wet. So the snow that morning had sublimed back into the atmosphere in Albuquerque. So it was now that was very low humidity, not low atmospheric pressure. But I thought of Mars.
Well, I understand in the Eskimo language they have about 12 different words for snow.
Yeah, that's because they live with all different variations of it. Now I think there's some circular features over here and here, and you
That's
can't
the Tharsis Plateau.
Yeah. And I think that these are the volcanoes.
Yeah.
Olympus Mons and the other one, I forget the name of it. But they're not high contrasty events. So
They're shield volcanoes, aren't they? They're very
Yes.
flat.
yeah, they're very flat.
Well, Olympus Mons is 15 miles high, isn't it?
Yes, it's very high. So but it's not made out of the same rocky outcrops as this one. It's a lava flow, and most of this is ash ejected and flowed down. So that is, in my view, that's what's ground up and forms the sand and dust that the rest of Mars is covered with.
Wow. And they don't have twisters on Mars, but they have little dust devils, don't they?
That's as best they can do. A dust devil, you hope that it hits your probe,
Yeah.
cleans it off. But we've got to bigger probes now that need more power, and so we send a little nuclear reactor up there, a thermal, I forget the
Radioisotope thermal generator.
Thank you.
What's it going to do?
Make electricity.
It generates power.
Generates heat, and there's thermocouples on it that compare the hot part to the cold part and generates electricity between the two from
And
their.
we also got to pick up all those samples.
The Seebeck effect.
Yes,
right?
Seebeck effect, yeah. Good physics. So this is a picture of Mars taken by Robert Casillas in December 24. Very nice image. He works with a C14 Edge telescope from somewhere in France. And he does every bit as good a stuff as Uwe Melling.
It's really blown out in this display.
Yeah.
Oh, is it? Okay, that's too bad because
They'll see something. He does that with his home telescope. He took that picture.
Yeah, it's a
Yes.
Celestron 14-inch.
Wow. Well, then you guys could do that. Oh,
There it is. Yeah.
Okay. Yeah, this is quite good. Now you see the diameter here down here is 13.4 seconds of an arc. At opposition next month, it will be 14. Not any significant difference from this. He also uses takes a video, seeing 7 out of 10, so it's not that good a night, but he takes it's a technique in image processing called lucky frame processing. And so you take a video of a lot of it, and the atmospheric turbulence will wiggle it and wiggle it, but every now and then you get lucky and it doesn't distort it. And so you grab all those sharp frames and you stack those and you get that. You saw with Uwe's picture of the moon, he was stacking 5,000 or 2,000 frames and taking the best 20%. That's not written here for this guy, but he's doing pretty much the same thing. He has several thousand frames and he stacked the best 10 or 20%. It does get a little tricky with Jupiter, because if you take too long a frame, you actually catch the planetary rotation and it blurs your features together. So you can't do it too long. But this is about what you'd see with a very good amateur telescope, say the 8-inch refractor on the Westmont College telescope, which is an absolutely outstanding fine detail planetary type telescope.
Does anybody know the magnitude right now? Naked eye watching?
It's negative.
Yeah, it's very bright.
Minus 2 or -1 at
Yeah.
least.
It's minus 1.2.
Okay.
And it's very red. It's apparent it's red,
Yeah.
red orange.
I apologize for not hearing it, but the MC equaling 236.8 degrees, what is that?
That's probably talking about what the Martian longitude is.
Longitude.
Yeah, what part of Mars you're looking at.
Oh, I see. Okay.
I don't know what it is in French, but here we would call it nadir.
Yeah.
It's the ground point directly below you that you'd have to go through to get to the center of the planet from where you're looking at it. So any other comments, topics, or anything? We've gone through our stuff just a teeny bit faster than I thought.
Is it Venus or Mars that has the same day and the same tilt as the Earth?
Mars.
Mars is closer, but the day is twice as long, isn't it?
Yeah.
Or no,
The year.
the year is twice as long. Yeah.
And Venus is turning the wrong way. It takes 200 years or 200 days to go around the. What was the deal on?
Yes.
The day is longer than the year. Yeah.
The speculation is that Venus was also hit by an object like the Earth was, but it reabsorbed all of the material or flung it deeply into space, so it has no moon. But that slamming gave it the rotation rate that it has.
Well, you started this program with the days on Earth getting longer over the millions of years.
Yeah.
You suppose they can measure or figure out how it's done on other planets? Like, was Jupiter ever going slower than 10 hours?
That would be real tricky to do, because here it's a very straightforward function. It's our moon moving away that's doing the energy drain. If you could somehow figure out how much angular momentum Jupiter is losing, then yes, it's a piece of cake to figure out what its rotation rate was and is.
But also, Ron, you have the complication that Jupiter is essentially a liquid planet, or fluid planet. So
Yeah.
different latitudes are rotating at different rates already. So it's tough to come up with some feature there. I think what they do now for some of these gas giant type planets is they look at how the magnetic field changes and try to figure out what the rotation is of whatever dense central part you have.
Well, I'll just bet they're all slowing down, all the planets.
That would be energy is going to dissipate through some mechanism, and so they are slowing down, but at wildly different rates. And the issue was, can you calculate what that rate is? And some of these things, it's so complicated, it's probably not possible.
But there's enough friction in the universe to slow down anything except, I guess, light. But do the Voyager 1 and 2 are they just going to go on and on forever and never? They don't run into any little particles that would be friction and slow them down slowly over the.
There's a thing I saw that I'm going to talk about next week. Two things. One is the North Pole is moving quite rapidly over towards Siberia from Canada. And the other, our North Pole, and the other thing is, if you were in Star Trek and you were going through our galaxy at warp 5, and you just headed a straight line, would you collide with a star? What is the probability that you would hit a star? And they've done a bunch of simulations, and the odds are pretty good you'd survive. So,
Really?
yeah.
And look at the number of spacecraft that we sent through the asteroid belt, and they survived.
Well, one of them hit.
Well, it doesn't look like it does in Star Wars.
Yeah.
No, it doesn't.
Yeah.
No,
The
that is-
average distance between anything more than about a kilometer in size is about 1,000,000 miles. So yeah,
Yeah.
it's pretty empty.
Yeah, they make for good adventure in the theater, but that's Hollywood still has a lot of astronomy to learn.
But I really can't understand these very distant 13 billion miles or light years away. How could light go straight to us without ever being affected?
It is
Passing-
affected.
What?
It
It
is.
is affected.
Well, then why don't we get nothing but lensing, just a big splattering all over, like, like a hall of mirrors at a
It's
sideshow
mostly
of a
empty
carnival.
space.
Because
Well,
the light
if
gets
you
bent around the massive object.
Yeah,
if you
It's
look at
circular
microwave
background.
frequencies, that is what you see. That's that cosmic microwave background. So most of that light has been red shifted way over into those other frequencies that we can't see. Plus,
I'm not
even-
talking.
even visible light, Ron, when you spread it out into a spectrum, you see what's called a Lyman alpha forest, which is all these absorption lines that are caused by this light going through clouds of hydrogen on its way here.
I'm not really talking about that. I know about the lengthening of the light waves. I'm talking about a straight line from 13.8 billion light years across, goes all the way straight without ever getting next to anything. Light can
Yes.
be.
Ron, the answer to what you're puzzled by is why we call space space.
Yeah.
There's a lot of it.
Yeah.
Well-
And we do see that it's interacted with hydrogen atoms on the way with protons and stuff,
Right.
because you get these absorption features in the light.
Right, but it hasn't it hasn't been deflected.
Right.
Like
So what was the guy's name? I've forgotten that
Olbers,
proved Einstein's, pardon?
Olbers.
No.
Hilbert's paradox?
No, Englishman. He proved that Einstein was right by looking at the star that moved that was close to the sun during an eclipse.
Eddington,
Yes,
Eddington.
Right,
Yeah.
right. So it did get bent.
But yes, it
And
does.
Ron, when it does get bent, it just looks like it's coming from a different place than it would have
Right.
really come from.
You just see the source moved over a little bit. That's how you can tell.
They
It's,
don't see that. They see exactly where they were. They're
No,
blocked.
Ron, they do see that.
yeah, no. When your eye sees a star, you assume it came straight to you, but you don't know that because you can't
Really?
see the path.
They
No.
get all. Well, how come they're not arriving as Einstein cross or whatever those things are?
Because that needs a really massive object in the way.
And very close alignment, which very seldom occurs.
Ron, like when I do these asteroid occultations, people actually have to take into account the gravitational lensing caused by Jupiter and the sun as the light comes from the asteroid or the Kuiper belt object. It has to be something pretty far away. So it does happen. And when you see it, your brain tells you, oh, it came straight, but it didn't necessarily do that.
But I never see that. I never see that represented. I just see it, in those.
Because we can't tell.
It's so small, so teeny.
Really.
Yeah.
Well, gentlemen, you've fascinated me, and you've driven my voice back to squawking. I guess we all have grandkids that we're going to be seeing around the tree, and we'll be back to do our very last one for this year, and that'll be number 201. But our closing program of 2024, everybody, happy holidays. Consider joining SBAU or watching any of the other 200 shows we've done, including this one. And we'll see you, I guess, next Monday morning. And then on the 3rd of January, we will be talking to Professor Damien from Cal State Northridge about extraterrestrials. Thanks a lot.
Merry Christmas, Happy New Year,
yeah.
Happy holidays.
And Hanukkah.
and I'll send you
Ditto.
the article tonight.